Hey there, welcome to new video. In my last video in this playlist, we got a very simple intro to vectors. If you don't have any idea about a vector, you can check out in the description. Now come to next move. Today, let's start with basic vector representation in graph. Let's go. Okay, we learned in our previous video that a vector is a mathematical quantity that has both magnitude and direction. Magnitude tells us how much of a quantity is present, while direction tells us which way it acts. Unlike ordinary numbers called scalars that only have magnitude, vectors require both pieces of information to be completely described. On a graph, a vector is represented by a directed line segment, or arrow. The tail of the arrow indicates the starting point, initial point of the vector, while the arrowhead shows its direction. The length of the arrow represents the magnitude of the vector, so a longer arrow indicates a larger magnitude. Subsidiary vectors are usually denoted by a capital letter with an arrow above it, such as A, to distinguish them from ordinary quantities. This graphical representation makes it easy to visualize how vectors behave and how they describe motion, forces, and positions. Vectors can be represented in different dimensions depending on the situation. In a 2D graph, vectors lie on a flat plane and are described using the x-axis and y-axis. Any vector in 2 dimensions can be expressed using these two components. In a 3D graph, vectors exist in space and require 3 coordinate axes, x, y, and z. The addition of the z-axis allows vectors to describe movement and position, not only left, right, and forward, backward, but also up and down. Understand? Therefore, 2D vectors have 2 components, while 3D vectors have 3 components. Like graphical representations in both 2D and 3D help us understand the location, direction, and magnitude of vectors in different environments. Vectors are extremely important because they are used to represent many real-life physical quantities. A force vector describes a force acting on an object. Since force has both magnitude and direction, it must be represented as a vector and is measured in newtons. And a velocity vector represents how fast an object is moving and in which direction, typically measured in meters per second, meters per second. Like in 3-dimensional space, a displacement vector represents the change in an object's position from one point to another and is measured in meters m. Another important example is the position vector, which specifies the location of a point relative to the origin of a coordinate system. While force, velocity, and displacement can often be moved parallel to themselves without changing their meaning. Sliding vectors, a position vector is generally a fixed vector because its starting point is tied to the origin. So, this was the graphical representation of a vector. Thus, vectors provide a powerful way to describe physical quantities involving both magnitude and direction, making them essential in mathematics, physics, engineering, and many real-world applications. Have any doubts? You can comment and check out the entire course or playlist in the description. I also uploaded the PDF of these pages in the description. Thank you for choosing in this video. Hit the subscribe button for more